Just going to get the recording going.
Will we ever even know how to go back to having in-person meetings? I wonder.
I think the whole, many organizations around the world are probably asking that question.
Exactly. What do you do? Dusting off a lot of old projection equipment. Anyway, we'll give it a minute or two more. There's usually some.
Yeah, there's still people streaming in. So.
Yeah, exactly. But this project has certainly gotten some buzz in Kingston. I saw a blog on Big FM the other day, and you know, the press was from the city and everything else. So it's this is very timely, hopefully for you as well as gaining traction on the next time you do this. So. Yeah, we got lots of good traction today.
I noticed that there's a phone number 613-888-6838. If you want to let us know who you are, I can rename you as with a name. Otherwise, still people streaming in. It's good. It's going to be a good audience today.
Yeah, I think this is our first geo talk in quite a while. I mean, we've had, over the years, we've had discussions about Drake's Landing out in Alberta a time or two, but that's not quite the same implementation, but it does use geo storage. So lots of ways to get to the end goal here. So that's good. Yes, a very good turnout today. Well, Ted, should we start? Are you going to be able to keep up with? Yeah,
why don't you start? People? I'll keep up with the people coming in and letting them in.
Okay. Yeah, and I'll let you handle switching people on and off for introductions. Anyway, good morning, all. We have a very good turnout today, which is very nice. Appreciate everybody's attendance on this quote unquote groundbreaking project in Kingston. We're joined today by Nastassja and Graeme, and we'll get a little bit more into them in a little bit. The first thing we always do at our switch meetings is a roundtable introduction. Given the number of people we've got today, please make it as brief as possible. Name and interest, or name and you know, one other tidbit, because we've got a lot of people to get through before we get to the main event. So since I got the floor, I'll start. My name is David Hindman. I'm the current president and board chair for Switch. I drive an electric car, and on Tuesday I'm getting an air source heat pump installed. So I'm trying to do my part.
Okay, I'm just going to go through the gallery that I have. John Beard, why don't you go next?
Good morning, all. It's John Beard, and I'm representing a not-for-profit senior citizens complex in Belleville, and it's for low-income seniors. Thank you.
Great. I see if Helene is there, although she's not in the picture. Harriet, why don't you go next?
Hi, Harriet Waterman, retired from the National Research Council and former board member of Switch. And like David, I drive an EV and I'm looking into heat pumps.
Great. Shannon Claggett.
Hi, I'm Shannon Claggett. I'm the Associate Dean Applied Science and Computing at St. Lawrence College, past president and board chair of Switch and still a present member of Switch, and just searching out my EVs. We can't decide.
Great. I have Steve Isco here, and then Shirish Suchak next, if you could unmute.
Steve Isco, retired academic. We have a heat pump and we have a Kona EV, which is awaiting a battery replacement.
Oh,
Great. Shirish Suchak. Oh, we can't hear you.
oh, still not getting you.
You might have to just type it in the chat. Maybe your microphone's not working. I'm asking a few other, okay, David Wilson.
Hi, my name is Dave Wilson. I'm in Lorneal, Ontario, and I've been promoting ground source for a number of years. And my buddy Bill Eggertson and I are working on Net Zero Canada.
Great. Rosie. Rosie,
Hi,
hi.
I'm Rosie Hyde. I'm a board member and the treasurer for Switch. And in my day job, I'm the manager for research and innovation services for Stantec. Thanks, Ted.
Great. Go back to Helene Kamal. Could you just quickly introduce yourself?
Hi, caught me off guard. Helene Kamal, longtime member of Switch. You should be too, if you're not already. Go team.
Thanks for the plug.
Okay, Lisa Martin.
Hi, everybody. I'm Lisa Martin. I am a small business owner, and I'm just interested in the sustainable living and all the topics here on Switch.
Spencer Bardell.
Spencer Bardell, technician of Kingston, owner of Bolt, Smart, EV, and Tesla. That's enough.
Okay, Mark Sibley.
Good morning. Retired from doing technical work in industry, and I have a Honda Clarity plug-in hybrid.
Barty Vorster.
Hi there. I'm a landscape architect and dying to have an electric car. Not yet.
I have Atma Anantram. Hope I pronounced that right.
Yeah, you got it. We're close enough anyways. Yeah, Atma Nancham from Amoresco, Canada. We do energy efficiency projects and develop renewable assets.
Okay, I have Darren Borden, and I'm going to call and Carrie to unmute. Darren.
Yeah, Darren Borden, Western Bakeries. I'm a corporate energy manager for EHS for the entire company, and I drive a Honda Volt, and I've been driving one ever since I could get my hands on one to talk the talk and walk the walk.
Great. David Garish.
Hi, I'm Dave Garish. I'm the energy specialist for Queen's University Facilities.
Darko.
Morning, Darko Matovic. I'm a board member, vice chair on Switch, retired recently from Queen's, involved in renewable energy, mainly biomass.
Okay, well, back to Chiari.
Good morning, everyone. I'm Chiari. I am professor at RMC, affiliated with the Queen's as well. I am board member at Switch. Thank you.
Great. Ian Kilborn.
Good morning, everybody. Ian Kilborn. I'm consulting in the area of energy management and energy auditing, commercial buildings, and just about to get recertified to do residential buildings under the Greener Homes program.
Great. Tatiana.
Good morning, Tatiana Zaremba. I'm your administrative director for Switch, and I live and farm north of the city. Solar expert, PV specialist. We own and operate for Zaremba Farms Solar, a 100 kilowatt facility, 7 years up and running.
Okay, we have Kevin Mccauley.
Kevin Mccauley, I work with Utilities Kingston.
And then String Man. If you want to put your name up there, rename yourself, that'd be great. But please introduce yourself.
But anyway, Steve Willoshin, retired from DuPont 18 years. I have a 19 kilowatt solar installation, and I'm a mechanical engineer.
Thanks, Steve. Devin Lake next.
Hi, I'm a Switch member recently, interested in renewables, worked in renewables 20 years ago. Currently mechanical engineer, doing lots of heat pump designs.
Okay, Nathan Splinter, do you want to go next?
Thanks, Ted. Good to see you again. Nathan
see you.
Splinger from Queen's University, energy manager, or actually now manager of energy and sustainability. We're building a couple of new builds at Queens, and they're going to be geothermally powered. So excited to hear a little bit more about what others are doing in the community.
Great. Andrew Martin. Then we'll go to Chad next.
Good morning, everybody. My name is Andrew Martin, and I'm a builder in the Kingston area, and always looking at finding ways to increase the energy efficiency of buildings.
Great. Chad, do you want to introduce yourself? Oh, you're muted though.
Unmute there.
There we go.
Let's do that. How's that?
Good.
Chad Joshi with Advonics in Brockville. We're a developer of renewable chemicals for personal care and industrial lubricants.
All right. Vicky Smolka, do you want to go next? Oh, if your microphone is working, hopefully. Oh, there. Okay, so let me read it out. Vicky, no camera or microphone today. Happy to be here to listen. Vicky's a former city councilor in the city of Kingston. Bob Hodgson.
Bob Hodgson, electrical contractor in Kingston.
Philip from Anchor Concrete.
Hey, good morning, Phil Searles. First time at one of these events. We're in the Anchor Concrete is joining the home building or building products for home building or construction. And also on a personal basis, we'll be building in the summer. So I'm looking to find more about more information about geothermal.
Okay, so I'm trying to make sure I check who I missed and who I didn't miss. Jordan Morelli.
Yeah, hi everyone, Jordan Morelli. I have a small business called EMF Mapping Canada, and I do consulting work as an electrical engineer, mostly in the solar field. And my day job is at Queen's. I'm a professor in the Department of Physics, Engineering, Physics, and Astronomy.
Okay, I have Harry Sullivan.
Oh, hi, good morning, everyone. Harry Sullivan, Executive Director for the Kingston Construction Association. General interest sign on this morning. We have a number of members that have been engaged and built some recent geothermal facilities, namely the St. Lawrence College Innovation Center, currently out at Kingston East Community Center, and as Nathan mentioned, the St. Mary's of the Lake revitalization for Queen's physical plant. So thank you.
Okay, let's see. We have Aaron Thornell.
Hi, folks. Aaron Thornell, General Manager of the Ottawa Renewable Energy Cooperative.
Carol McKay.
Just an interested participant, Ted.
Okay, Carol's very interested in hydrogen.
Yeah.
Matthew. Matthew Gventer.
Hi, I'm just interested in this issue and the environment, but I was advocating for geothermal at the new high school in Kings Court, and it wasn't done although it would have been a good place to have it.
And I agree with that, Matthew. Okay, I have David's iPad. I don't know who that is.
That's me. Can you hear me?
Yes.
Can you hear me? It's David Hahn. Sorry. I'm struggling with my technology. I guess I could say I'm retired president of Wintergreen Co-op, but I'm interested in heat pumps and so on for my house. And I've been driving for 3.5 years at e-golf.
Okay, great. Let's see now. I have some phone numbers here. And I forget how to unmute a phone. So if you can unmute, please do right now. There's somebody 613-885-7487.
Richard Jones, RJ Specialties down over here in Picton. I've done several hundred geothermal installs, commercial and residential. Do mostly solar though. And I just wanted to join in. I just only have a few minutes, but wanted to hear what I could hear while I could.
Great, thank you. There's another phone number, 888-6838.
Hi, I'm not sure if I unmuted myself successfully. It's Mike Kiefel, Anchor Concrete. I'm accounting manager here. Very interested in renewable energy, and Anchor is in the sustainable building market. So we're looking to see geothermal can apply to multi-unit structures.
Great. I have two. There's Marion. Marion, would you like to introduce yourself?
It's David again. I just switched from my iPad to my desktop. Sorry.
Okay. No problem. Okay, and then there's somebody labeled admin, the last person I have here. If you'd like to introduce yourself. No? Okay, why don't we wait?
Did we miss anybody?
Well, we have Lisa Asbrook joining, our energy lawyer who can make all sorts of things happen. Lisa, can you introduce yourself quickly? Are you there, Lisa?
Yeah, good morning. Sorry,
there.
I was trying to come in subtly.
Sorry.
It's okay. Lisa Asbrook, business lawyer, energy lawyer, partner at Cunningham Swan, downtown Kingston, working away on renewable energy law and policy in our area and across Canada.
Okay, great. Thank you. So please use the chat to talk to each other. And David, I'll pass it back to you to introduce our speakers.
Alrighty. Well, thank you. That was a long list, and we again thank everybody for attending today. Obviously, lots of interest in this new development in Kingston, and we look forward to the discussion. One more sort of housekeeping item before we get to the main event, and that is to thank ever so much our new and renewing members. On the small corporate side today, we have Canadian Wool Austenite renewing. Bob Vasily gave a very interesting talk a while for us. Individual members, Carrie, I'm not sure if I caught you last month, but I'm catching you again this month. And we have William Egnatoff and Devon Lake renewing. And as Helen said, you know, if there's anybody out there that is not a member that would like to be, individual members are only $50 a year. So that's pretty reasonable for the content that we try and get out to our members, and you know, to anybody who cares to show up. So, but membership will obviously help us keep the lights on and the activities going. So today, the main event, and we'll let Nastassja and Graeme introduce themselves a little bit more. We've got Podium Developments talking to us about the project at 575 Princess Street, first major geothermal in the city, which is very, very exciting. Thank you, Ted, for tracking this lead down for us. And obviously there's lots of others today who think this will be very, very interesting. I could read the you know, the spiel that's on the website, but probably better just to get into the meat of the presentation. So to that, I will pass it back over to Nastassja and Graeme, and let them run with it, because hopefully, I'm assuming there'll be lots of questions at the end.
Great, thank you so
Alrighty.
much. Thank you so much, David, and for everyone for having us here this morning. We're really excited about this project, and we're excited that people in the community are excited about this project. So looking forward to share with you. So I'm going to get my screen share going. And I believe you should all be seeing it now. I see the heads nodding, so that's a good sign. Just got to wiggle my Zoom out of the way. And all right, okay, we're ready to go. So yes, my name is Nastassja Pearson. I am the development manager with Podium Developments for the 575 Princess Street project. I'm here with my teammate Graeme Smith, who's the construction manager on the project, and we're going to just be walking you through the geothermal design process that we took to get here, taking a look at construction, taking a look at where we are today with this project. So we'll start with a quick intro to Podium Developments for those of you who aren't familiar with us. We'll then look at a really quick overview of what the building actually is and what's going on there. Because I'm not familiar with what everybody's level of understanding with geothermal is, we'll take a look at the basics and the high level of how a geothermal building, how a geothermal system works in a multi-unit residential building such as this one. Then we'll dive into some of the details about the design considerations we had to make when fine-tuning the system for our project, and their considerations that you'll have to take a look at when looking into geothermal for any project. I'll pass it over to Graeme, then we'll go into the system design that we've done to date, sorry, the system install that we've done to date, walk you through some pictures. His portion is probably the more interesting side. We'll talk really briefly about what we expect with operations, and then I know because it's such an engaged group, we'll try to leave as much time as we have for questions and discussions at the end. So Podium Developments, we are a developer and builder founded in 2014 with a successful track record of rezoning and developing a lot of urban infill locations across Southern Ontario. Many of our projects to date have been purpose-built rentals with a focus on student housing. They're not necessarily exclusively student housing. We just find project sites in areas where that seems to be the key market, and it's been going well for us. Our most recent development, we just actually had the grand opening this week in Kingston, is at University and Princess. Looks very much like this rendering. It's Unity Point, it just completed there. Across the street, we've got Unity Place going, and then just up the street, I guess further west on Princess is where 575 is. We've completed 18 projects to date throughout Toronto, Oshawa, Barrie, and Guelph. I would say at least half of those have been in Kingston. We currently have 9 more projects under development, and we've taken the stance that on all our new projects, we really want to focus on resident wellness and where we can incorporate low carbon design or zero carbon construction into our projects. 575 is one of those projects under development right now. So 575 Princess has recently been named Geo, so that's the name of the building. It is a 10-story purpose-built rental building located between Frontenac and Albert Streets along Princess, so it does occupy a full city block. The building will be a mix of unit types ranging from studios to 4 bedrooms, as well as a few townhomes along the Frontenac side. There'll be a large fitness center, a squash court, multiple terraces, rooftop amenity, and we've also have space carved out for a park at the corner of Frontenac and Princess for the community to enjoy. This was a brownfield redevelopment site where a significant amount of contaminated soil and bedrock was removed to allow for 2 levels of underground parking. On occupancy, 20% of the parking spaces will be equipped for EV charging, but the building has been designed and sized to have a capacity of up to 90% EV charging. So we're doing our best to future-proof and plan moving forward. The building will also be looking for Fitwell Certification. Fitwell is a certification program that focuses on elements of the building that improve resident wellness. So walkability, what amenities are nearby, how are the spaces designed, what materials are used to make sure we have good indoor air quality, just promoting general health of the occupants beyond things related to the physical construction of the building. And lastly, what you've tuned in for, this project is the first large-scale multi-unit residential geothermal building in Kingston. That's exciting, and we're happy to share that with you here. So I did sit in on a switch presentation a few months back, and it wasn't a geothermal presentation, but one of the questions that came up was why aren't more developers using geothermal, or why isn't geothermal happening more? And I can't speak to why others aren't doing it, but what I can speak to is why we've decided to go the geothermal route and why we're evaluating it on future projects. So firstly, we want to lower the carbon intensity of our builds. We know that the carbon targets in 2030 and 2050 are looming, and a lot of municipalities and areas have said, we need to reduce carbon footprint, but ultimately we have to take a step forward and actually start doing it to see change. Kingston was the first municipality to declare a climate emergency. And with all the work that we do in Kingston, when we realized we had the opportunity to incorporate geothermal in this building, that it was a good fit, we wanted to jump on it. Oops, sorry about that. The next driver for us is that we really want to be industry leaders. Although the code hasn't mandated that net zero is a requirement yet, 2030 will be here before we know it, and change is scary, and change takes time to adapt to and become comfortable with. We didn't want to be left behind trying to scramble or figure out what the most efficient way to design and construct geothermal buildings would be. So we decided to start on it now when the opportunity presented itself. The next reason is what seems like a really large extra capital at the beginning of the project, when you're used to conventional building construction, is actually, we're finding less intimidating to our investors and the teams that we're talking with on these projects. They're actually looking for to invest in projects that are considering sustainable construction, low energy, renewable resources, because they're in it for the long haul when we do these purpose-built rental buildings and these long-term investments. So they want to know that they're future-proofing their projects as best they can, trying to hedge any costs associated with any carbon taxes or increased energy costs. So this is actually something that we're seeing investors want, is that they want to invest in projects that are using these technologies, such as like geothermal, or looking for low carbon certifications. We're also seeing that end user expectations are shifting. Walk-in closets and quartz countertops, those are still at the top of the list of end users, but things like energy efficient appliances, energy efficient HVAC equipment, high insulating walls and windows, ERVs and HRVs have also broken into the top 10 list of things that people want in the spaces that they're living in. Especially now that end users are more aware of the footprints and the costs associated with the spaces that they occupy. Lastly, we wanted to provide a standout product in the market. So with all the other factors just noted before, by doing good by the environment and the investors and the end user, while still being able to showcase a product that nobody else has in the market, is a great opportunity for us and a win on many levels. So it just made sense to dive into geothermal. Now I'm going to go into the basics of how the system operates. So this may be very familiar to some, but maybe new to others, and I think it'll just provide some help in understanding the pieces as we move forward to the other parts of the presentation. So at a high level, we've got our building, we've got the ground. So the geothermal wells are the very first thing that goes in. These are a series of boreholes drilled into the ground, either beneath the building footprint or adjacent to it. Those wells are connected by what I'll call the horizontal loop. That horizontal loop then ties in through, or is consolidated and comes into a series of manifolds, and where it meets into the basement of the building, where we've got the pumps and the heat exchangers. Those then transfer the energy taken from the ground into the building loop that runs through the whole building. And that building loop is connected to the individual HVAC units in the building, where the spaces are conditioned, sorry. The ground loop itself is very simple, very streamlined. There's not much going on there in the sense there's no pumps, there's no mechanical equipment or anything happening in the ground. The system is driven by convection of heat transferring from the fluid in the loop to the ground and back and forth as it moves through each winter and summer cycle. In winter, let me get the pointer out, might be helpful. So in winter, what's happening is we have heat from the ground moving into the loop. When it then goes up into the building, it's then pumped into the building loop, and each individual HVAC unit that's tied to that building loop will pull heat out of it. The heat pump within the unit will then expel that heat to the space and the return fluid that goes back into the building loop is cooler. It then goes back down into the ground, where it circles through the main geothermal loop, and the ground temperature heats the fluid back up again, and the cycle continues and continues. What happens with that, though, if you're looking at just the winter season, is that compared to the starting point at the end of the winter cycle, your ground temperature will have cooled down a little bit because of all the heat that's been taken out to go and provide heat to the building. Where that gets corrected is in the summer when the operation flips. So what we have happening in the summer is that the spaces are conditioned, so heat is taken out of the air within the unit and put into the fluid that then runs down into the building loop. That building loop fluid then goes and runs into the ground loop, where that heat then is put back into the ground. The loop temperature that goes back into the building is relatively cooler, and then that cycle can continue again. So where we started ending off the winter season with a cooler ground temperature, we're now going to come back to a place where we're balanced. And this constant cycle of cooling and then coming up and balancing, and cooling and coming up and balancing, is what makes the geothermal system work, and what makes it so sustainable long-term for heating and cooling. Near the surface of the Earth's temperature, near the surface, the Earth's temperature fluctuates with the season, but in its natural state, a few hundred feet down, the ground temperature is essentially constant. If the balance of the Earth's temperature deep within the ground where the geothermal wells are located is maintained, the system will just work in perpetuity. It'll just keep going. But it's when things aren't balanced and when that overall temperature of the ground surrounding the well system isn't maintained that you start to potentially see problems with your system. The failure of the system wouldn't be instant, but it is something that can creep if left unattended over time, if the system either isn't monitored or balanced in design. And the failure, what happens is that the temperature shift within the ground just goes beyond what the workable temperatures of the heat exchangers are. And obviously this is something that we want to avoid, as retrofitting a building with a conventional system after a geothermal ground loop failure is extremely costly and disruptive, and not something we want to do. So constant monitoring of the system is important. We'll now go into the design considerations that we looked at specifically for 575 Princess that really affected the system balancing and where we ended up with our design. So the very first thing that we start off with when looking to do geothermal is understanding what the geology is beneath the building, or sorry, beneath the ground. They'll do a test borehole, I think we did 2 test boreholes at 575 Princess. I think we went down around 600 feet for each borehole, and the borehole comes back and tells us what the geology is, where the water is located. Are there any aquifers? Is there any potential for an open loop system? And then they'll run a conductivity test within that borehole to just really check that all the assumptions made about the properties of the rock and the properties of the soil are correct and able to use for design. Bedrock is a great medium for geothermal. It's highly conductive, it's dense, it has a high specific heat capacity. However, it's quite harder to drill in compared to just soil, till, whatever else you might find above it. So it's great that it's a more efficient medium, because it means that you can provide a much smaller ground loop to produce the same amount of heat compared to a system where your bedrock is very deep. If you have to dig really deep to get to bedrock, you will need obviously like deeper wells, or you may even need a larger system. And understanding the subsurface conditions and how many wells you would need, how deep you need to go, it's a bit of a math balance there to see where is the threshold as far as what makes sense for your project in terms of cost, benefit, and feasibility. In theory, a geothermal system can work for any site if you just drill deep enough or put in enough wells, but it's easy to see that that may not be practical or feasible for your project. The next thing that you take a look at once you've understand what the earth can provide you is whether or not your building is considered a heating or a cooling dominant building. A heating dominant building is a case where more heat is taken from the ground than is put in on an annual basis. And without intervention, at the end of the year, the ground will end up being a bit cooler than what it started. Possible interventions to help mitigate heating dominance would be to connect a domestic hot water boiler or to connect a supplemental boiler to your heat exchanger to help bump up the loop temperature and supplement heat to the units. What's great about geothermal is that, yes, the loops are going through the ground and that's where the heat transfer is taking place, but ultimately the loop doesn't fuss about where the heat comes from. So if you need to supplement with heat from another source like a boiler, or if you've got a really creative design team and you can figure out some sort of maybe like reverse snow melt where you're absorbing heat in the summer to put back in the system, you can get really creative. It's really just about getting heat into the loop. And there's ways to do that depending on how creative your team wants to get. On the flip side, a cooling dominant building is one that does not put enough heat back into the building, or sorry, back into the ground loop at the end of the year, and that it's cooling more than it heats. This type of imbalance in cold climates is actually a bit easier to manage, because what happens is you have an excess of heat in the ground at the end of your cooling cycle that you need to expel. So you can find ways to expel the heat through like heating your parking garages, snow melt systems, preheat water, because you've got this abundance of heat. What is interesting though, even though this cooling dominant, sorry, I'm going to restart that. So despite our cold winters, a lot of multi-unit residential buildings in Southern Ontario are actually cooling dominant. So we've got these long cold winters and you think we would be pushing heat out all the time, but because of these glass box multi-unit residential buildings that you see a lot of places with high glazing ratios and not necessarily the best thermal performance of the wall assembly, we're actually in a situation where we've got a lot of cooling dominant buildings, which just shows you how much cladding design and the geometry of the building can actually impact the space conditioning demands. Which brings me to the discussion about building performance and the impacts that that have on your geothermal system. So building performance in terms of your HVAC systems and your enclosures and air leakage rates always matters, whether you're doing geothermal or not. It's important to make sure that you're doing everything you can to have an efficient and well-performing building. But with geothermal, we had to take a close look at it, because if your building is not performing as optimally as it can, what happens is the scale of your system increases and the demand that you need to make up for increases, which means your well sizes increase and your geothermal field increases. And that's where the biggest cost associated with geothermal is. As you saw, the system itself within the building is some pipes and some pumps and the HVAC units, which are already in the units anyways. It's really drilling the bore field that creates the biggest cost increase. So to make these projects viable and attractive, we need to do everything that we can to keep the building efficient. So looking at things like air leakage and what are you doing to create a tight envelope, insulation levels and thermal bridging can become a big issue where a lot of heat is lost unnecessarily if we could just be more smart and efficient with our design. Solar gains on the flip side is, are you allowing the space to become too hot? And what control measures are you putting in place to help mitigate that. And then also with the envelope, mechanical system efficiency is always tied really closely. I'm sure many of you heard the phrase like seal tight and vent right, building science mantra for life, but high efficiency ERVs and HRVs and heating units are needed to recover some of this heat that we ventilate again, so that we're not just getting rid of everything that we then need to reheat and put a lot of effort and work on the geothermal system. One topic that we had a lot of discussion about on our project was ventilation rates and when we need to ventilate and how much we need to ventilate. And an idea that came up was like, let's ventilate based on sensors and CO2 sensors throughout the building rather than timers, to just make sure that we're not venting more than we need to and not putting added load on our geothermal system. At 575 Princess, we actually went away from a window wall cladding system, which is what you typically see on a lot of multi-unit residential buildings from developers. We've got framed insulated walls, a glazing ratio. I think we're a bit lower than the 40% mark. And our building worked out to be heating dominated. So to account for that, we did upsize the domestic hot water boiler to allow for supplemental heat injection if needed. So we were talking about ventilation and air changes and how that can impact the loop size. And so one thing that our design team had to work through was the occupancy considerations and what was expected versus what was the absolute worst case possible maximum. So our designers, we were working with Diverso Energy and they were great in providing a lot of insight in how to try to keep this geothermal system as lean as possible. And our mechanical designers, they were less familiar with it and used to this concept of like, well, we need to design for this happening on top of this happening, on top of this happening, on top of this happening, which wasn't necessarily realistic or something that would happen often enough to warrant designing the system to such a large scale. So we had a lot of discussion about peak design, high factor of safety versus going a more lean approach and targeting it on what's needed. So occupancy rates and max design occupancy compared to actual expected occupancy, was one of those considerations, because you can see from the schematic here that if you're designing for your absolute max possible occupancy, you're going to have higher ventilation rates, you're going to have more turnover of the heat through the system, and your overall geothermal loop will need to be bigger to accommodate that larger load. Whereas in actuality, based on our market research and our experience on other projects and just understanding our end user, we were able to come to a middle ground where we expected the occupancy to be a little bit less. We were able to scale down the anticipated design ventilation rates, and then again, put in a more moderate size well system that was a bit leaner. It still has some redundancies and factors of safety, but maybe not as grand or as extreme as what would have gone forward with like a conventional mechanical design. The other occupancy related question that came up for our project was the idea of seasonal occupancy. And this was something that our designer had actually not dealt with or had experience with. And what it was is, although our building is not a student residential building, we know the market, we know the population, we know where it's located in town, and we can anticipate that there will be a high percentage of students that will live here and come and rent here. And with that is, are we going to expect that a portion of them move out for the summer? What's happening in the summer when potentially, when potentially a significant number of occupants move out, and you're counting on that summer use of the air conditioning to put the heat back into the system and balance things out. And that was exactly it. We said if people move out and we aren't able to put the heat back into the system, we're going to be left with a colder ground loop on the annual basis when we're looking at those balancing cycles. So again, being a heated dominant building, as well as this question about seasonal occupancy, it just furthered our decision that we're going to make sure that we include a supplemental, or sorry, that we upsize the size of our domestic hot water boilers so that we can provide supplemental heat to the system if needed, if it happens. There's a lot that goes on that we can only put our best laid plans forward and make sure that we're prepared for what comes up, but we'll have to see how it actually runs in operation. So some final points on the design consideration side before I pass it over to Graeme is that I think from those few slides, you can see that there's many combinations and permutations and different ways that things can come together that can affect the swing of your system and where it hits that balance mark. And so what's important to understand is that it's not a one size fits all design. You cannot just take the design that you used at one building and put it to the next one and say, okay, I'm good. You need to come to the table with a blank piece of paper, get all the heads of the brains involved and say, what could this happen? Could this happen? What do we need to consider here? And just try to anticipate all the different scenarios as early as possible to try to streamline your design and nail down as much as you can in the early days to avoid costly changes or issues coming up in the future. It is an increased capital cost over conventional design, but there are financing options available. I think I had mentioned Subterra, Diverso. I do think there's some banks even that are offering financing. I believe Van City was one of them. However, when you're looking at these projects, you're not necessarily going into the mindset thinking about how much more you have to spend right now, but it's a long-term overall savings. Our investors are looking at a perspective that yes, we're spending more now, but in the grand scheme of things, we're going to be saving, we're going to be doing the right thing, and we're going to be providing a solid long-term product for the future. And when you think of it that way with a long-term lens, you can slice and dice it many different ways, whether you're financing, whether you're paying it out front, to see that it's a smart economic choice. Drilling the wells is the largest cost associated with the system. So doing everything that you can to reduce how much you have to drill and how deep you have to drill will help with the cost issue or the cost barrier that a lot of people probably see with geothermal. So push your mechanical designers to think out of the box and come up with alternative solutions, and maybe think about things in ways differently than they would have. Like mechanical designers may want to, again, put in these large factors of safety to make sure that they've got all their bases covered. But with geothermal, it's very, it's extremely important and beneficial to get a bit more aggressive with the design and think about what you're really going to experience and what's really going to be there. Building efficiency and performance matters as well. Good envelopes are always important, and not something that not something that you could just forget about with this. Envelope and mechanical are always very closely tied together. You should also consider that geothermal, you may not just be able to put in the ground loop and call it a day and that's it. You don't need everything, but that you may need some intervention or some sort of supplemental support to help balance the system on an annual basis. Ultimately, that balancing is the most important thing. Otherwise, excuse me, otherwise you may lose efficiency over time and your system is just not going to perform or potentially ultimately fail if you're really careless with it. And lastly, the net zero considerations. I didn't go into this in too much in too much detail. As this building, we weren't trying to get to net zero, but we were trying to do significantly better than what it would have been had we gone with a conventional system. So if you are looking for net zero, you need to think about things, this idea of like supplementing with domestic hot water. What is the fuel source for that domestic hot water? And whether or not that's going to impact your net zero considerations. The ground loop fluid, for example, If you're using water in your ground loop, there is a chance that it could freeze if we have an extreme cold snap. So do we need to, again, provide more supplemental heat to just make sure that that doesn't happen? Would you rather consider like a glycol system or something that has less potential of freezing in the ground? That may help with hitting some of your net zero or low carbon targets. However, there is some efficiency loss with glycol through all the heat transfers compared to water. And ultimately, geothermal itself is not what is the net zero portion. There's a lot of energy associated with using a geothermal system. We have the pumps, we have the heat pumps, we have the HVAC units in each residential unit. And unless you are connecting to a grid that is clean and low carbon, you're not actually going to get the low carbon savings with a geothermal system. Thankfully, in Ontario, our grid is really clean, and this is an opportunity for us and a benefit for us. But if you're in a different market, that may not always be the case. Also, just the electrical capacity of the system that you're working in. We had a lot of discussions with Utilities Kingston to make sure that with all the heat pumps and everything that we're running in this building, that the overall capacity of the system would be okay. We worked through that, but that it is something that you would need to discuss. And I think it's something that utilities need to discuss and pay attention to moving forward, knowing that a lot of builders and even just personal homeowners are going to be making the shift. So it's important to make sure that the overall capacity and supply of the system that we're drawing from is there. Excuse me. I'm going to drink some water and then pass it off to Graeme, and he's going to take a look at the system install.
Hey, good morning, everyone. So as previously mentioned, my name is Graeme. I'm a construction project manager with Podium Developments, and I'm responsible for executing the construction phase at 575 Princess Street. So today I'm going to be covering some items regarding geothermal install on site, so pre-mobilization, some other project considerations specific to the install, the actual installation process itself, and then we'll briefly touch on a couple schedule considerations that should be mentioned as far as working geothermal into a construction project schedule. So to the next slide. So system install, so some things to look at kind of before we even start. So really the biggest thing is gonna be some bulk versus local excavation. So that was really a big factor in our site, something that really took a lot of thought into and how we're gonna execute that phase. This ties into the drill rig access requirements and limitations. So there are some things to consider there with just how exactly we're going to get that equipment into the building excavation to commence that drilling work. Also staging for geothermal, contractor, their equipment, their material, how is that going to work around other trades in that excavation area, and how is that going to affect our phasing? And also a big factor was our dewatering and spoils management. Obviously, throughout that drilling process, there's quite a bit of material that's ejected from the ground, and trying to manage that in an efficient and clean way on site was something that took a lot of care and consideration. So you can probably move on to the next slide, Nastassja. So here, kind of our pre-mobilization items. So the photo on the left represents what our site looked after our initial demolition. So that was our existing grade that we were left with before we started any of our excavation on site. So photo on the right, some earlier stages of the bedrock excavation. So one thing is tying back to the bulk versus local excavation. So with local excavation, it's obviously more efficient for us to detail that excavation to be specific to the footing design. So varying levels, keeping the excavation as shallow as possible, and minimizing the overall tonnage of rock removed. For us to try and make room for both the wells, the horizontal loop piping, as well as the rigs themselves, we had to kind of go down to a common elevation. So you can see in the photo on the right, the wood lagging represents the soil that was removed, so very relatively shallow amount of soil. And then below that, obviously the bedrock going down 2 stories of underground parking, plus some additional space to make room for that geothermal piping. On the previous slide, so a couple of questions have come up in the past where could we have done some of the drilling from that existing grade. And although it was possible, just looking at how complex that bedrock excavation is, we really didn't want to impact that at all. So we were kind of on previous sites noticing some large slabs of limestone coming out during that excavation process. So we thought there'd be a high risk of damaging those wells if we chose to try and do some of that well drilling before the bulk bedrock excavation. Maybe next slide. So again, some more detailing of our bedrock. So on the left, you can see some pretty large equipment we used to kind of get down that deep. It really was pretty challenging. We encountered a lot of areas of really dense hard bedrock, especially on our site. So it took quite a bit of work. And again, going down a little more bedrock than we would normally excavate to make room for that geothermal. It did add some considerable time to the project. The photos on the right, so they can represent. So the top right there is kind of our final bulk excavation level. So you can see there's no real variations in the base of that excavation. It's relatively flat. And again, that was executed in that way to one, just mainly allow for the drill rig access and efficient drilling on the site. To touch on the drill rig access, so the equipment used on our site were not all-terrain drill rigs. They were just kind of a standard commercial truck with drilling equipment fastened to them. So here's a couple of photos of the trucks themselves. So obviously need a relatively stable flat base to be able to work from. And not only that is actually getting these things into the excavation. So throughout excavation, we would have a temporary ramp installed that would be used for bringing material in and out of the excavation. We then had to remove that ramp to remove the bedrock from underneath it, and then reinstate that ramp with engineered material just to bring this equipment into the excavation. So if you want to go back one slide, sorry, Nastassja, we did have a couple areas where we did actually need to do local excavation. So some stuff like elevator pits that will go down quite a bit farther than our bulk excavation elevation. So we were actually filling in those areas with clear aggregate to kind of make that nice, smooth, stable base for those drill rigs to get in. You can probably jump ahead. So here we can kind of get an overview of our staging setup with the geothermal contractor. So generally when we're excavating a site like this, as the excavation is progressing from one side to the other, we'll come in right behind them with our formwork contractor and start constructing the footings for the building. Just giving the amount of space we needed for the geothermal contractor to kind of do their work, really pushed out that overlap and really needed to leave a large area for the geothermal work to occur. On the right hand side, you can get a general overview. So on the bottom right, we have some of the piping material. So those are the reels of pipe that would actually be inserted into the borehole wells. We have tool trailers. In the middle there, you can see some containers we were using to manage the spoils from the drilling process with a couple small pieces of equipment, again, there for geothermal support. And in the back left, you can see some tarps. That's actually all bentonite, dry mix bentonite material that was being stored on site as well. So overall, it's a pretty large area that needs to be considered to set up an operation of this size. The photos on the left represent some of a bit of the process that we were using to manage the dewatering and the spoils management on site. We tried a few different options to try and find something that's most efficient and the cleanest solution possible. And so here we're actually discharging spoils into containers, letting that sediment rest, and then skimming off and filtering the water off the top of those containers into our site dewatering system. So it's a sophisticated dewatering system using large sediment tanks as well as multiple filtration units before discharging off the site. So the middle photo there is an item called a vortex. So from those drill rigs, the water and the flow rate of the water and the spoils coming out of those rigs is pretty high, and it's actually quite dangerous and creates a bit of a hazard for your working area. So that unit there actually is filled full of baffles that will slow down the discharge from the drill rig and makes a much cleaner and safer environment for guys to kind of work around in the area. So next slide, Nastassja. So now we're kind of getting into the actual well installation itself. So on our site, the wells were approximately 400 feet deep, and I think we had just over 100 wells. The drill rigs were using a carbide tip bit to get down to that depth, and Generally, in our case, we're using almost one drill bit per well. So just trying to get through that bedrock was quite challenging and is very strenuous on the equipment they were using. Once the well had been completed, they would they clear out the well with either water and pressurized air, and then they would feed these the geothermal pipe into the borehole using that blue reel on the left photo there. It's a hydraulic reel. So there's a lot going on there. Actually, you see a bunch of hoses kind of connected to that. So after the pipe is initially inserted into the borehole, they're actually filling the pipe with water, and it's the weight of the water that's actually pushing that pipe down to the bottom of the borehole well. So after that's been fully inserted, they'll do a quick pressure test on that pipe to make sure there's no breaching of the casing, and then they'll actually fill that entire well full of bentonite. So Nastassja, correct me if I'm wrong, but that bentonite is one, just obviously helps anchor that piping within the borehole, but two, it actually kind of improves some of the thermal efficiency of the how that interacts with the bedrock and the surrounding area around the borehole. So all of that bentonite is mixed on site, so it's shipped to site, dry mix bags, and it's mixed almost in a piece of equipment similar to what shotcrete would be done for a swimming pool or those types of things. So and then the photo on the right is kind of what a completed wellhead would look like. So there's a small steel casing, and you can see kind of it's filled to the top with bentonite. So that steel casing is removed once the bentonite's either solidified or just before connection to the horizontal geothermal loop. So here's a pretty good overview of what our site looked like after we completed all of the well drilling. So you can see all the wellheads are approximately 4 to 6 meters spaced apart across almost the entire site. We strategically located the well to avoid some of the larger footings like the tower crane bases, obviously elevators, and they were placed to avoid any other under slab mechanical works, the things like that. But you're kind of getting an overview now that it is pretty dense down there, and it does create a bit of a challenge when trying to work around these with other trades, other equipment, as trying to narrowly kind of miss a lot of these wells and not risk damaging any of them. So on the right, again, another photo, you can kind of get a sense of the excavation depth of 575. So again, we're roughly 2 meters deeper than what was needed by design, basically just to accommodate all of the piping and everything that would be running under the slab, and ensuring there were no coordination issues with the sub-slab sanitary piping. And sorry, maybe I'll touch on the left photo there. Sorry, Nastassja. This photo is actually taken to the top of this ramp. So you're getting a sense of this 2-story tall ramp that's been made out of crushed limestone and smaller crushed aggregates. So pretty significant piece of the excavation to be able to facilitate access in there for a lot of this equipment. So now we're getting into the more exciting stuff, the actual under slab piping connection. So we'll start with the photo on the left. So based on recommendations from both the geothermal designer and our local building sciences engineer, they did not want the piping resting directly on top of limestone. They wanted some form of bedding between that pipe and the limestone. So we started off with a very thin layer, about a 6-inch layer of granular A material that was spread across the entire site and then compacted. So again, keeping in mind that all of this fill we're putting in back here is going to be the bearing capacity or the bearing material for our slab on grade. So it does need to be placed in lifts and compacted to ensure there's no structural issues. So you can see kind of on the bottom left there, you can see the one wellhead sticking up. So it does get a little bit tricky where we're not able to kind of blast through with larger pieces of equipment to expedite that backfill. It has to be done quite carefully to ensure you're not damaging any of that pipe. The photo on the right, we now have this initial layer of bedding completed, and the horizontal piping runs have started. So you can see the smaller 1.5, 2-inch pipe coming up and connecting in a 90-degree elbow from the wellhead, and then transitioning over to the main piping runs in the main horizontal loop. So those pipes start off as a 4-inch pipe, and they'll taper down to 3-inch pipe as they approach kind of the end of those runs. And as you can see, they're running pretty well extensively throughout the entire under slab area of the building. There wasn't really too many areas where we didn't have wells in this situation. So now we're getting into the piping, the actual fittings and connection type. So I found this quite interesting. All of the pipe here was actually connected using heat fusion welds. There's no adhesive used in any of these connections. So both the pipe and the fitting would be heated up with a specialty piece of equipment. inserted, left in a jig, and then after a certain amount of time, once it was deemed that that connection had set, be removed from the jig. So there's a few standard connections here. It looks very similar to some of the plumbing in your own home, where you have a kind of a male and female end of a fitting adapter. That'd be one type of connection. We also had saddle welds. So in the photo on the right, you can see one of the branch lines and where it's connecting to the main run. That has to be a field connection. There's no real efficient way of prefabricating that offsite. So that there's a nipple there that's actually heat welded onto the main pipe itself, and then the hole is drilled out after, and then the final connection for the branch piping is made after that. With the main 4-inch piping runs also, obviously we're going to have to introduce construction joints throughout the excavation just based on just the stock material length. So there's butt welds that are completed in the field. So where 2 pieces of those 4-inch pipe are fused together, again, just with heat, and left in a jig to set for about 10-15 minutes. And then once it's deemed set, they would remove from the jig and continue on with their next connection. So kind of pretty fascinating. No adhesive used anywhere within the system. And lastly, kind of getting into our backfill process now. This proved to be pretty challenging. So the backfill for the slab on grade is definitely a critical path item that can be expedited on a lot of sites, where you can throw in a lot of fill with heavy pieces of equipment, larger pieces of equipment, and really improve on your schedule. In this instance, having to do some detailed backfill around all these piping connections was pretty labor intensive. Based on recommendations from, again, the geothermal designer and our local building sciences engineer, we needed to establish a clear lift about 18 inches above all of our piping runs before we were able to drive heavy pieces of equipment in. So that was a lot of really detailed, slow, careful backfill around all this piping to be able to establish that. Before we obviously get into that, all the piping is pressure tested. So it's initially tested at 100 PSI for about 48 hours. And monitored to see if there's any leakage in the system. After that, the pressure in the pipe is lowered to make it a bit of a safer working area for other trades, but we do leave pressure in the pipes throughout the backfill process. So we're constantly monitoring all the pressure gauges on each run to ensure that there's been no damage or nothing's been touched during that backfill process. The photo on the right, you can now start seeing some of the bulk fill being brought in with some of the exposed piping in the back that was still undergoing its pressure testing phase. And now we have the completed backfill. So I don't know if anyone's noticed, but you can kind of just based on where some of the concrete structures are, you can see we brought in almost over 1.5 meters of fill to bring us back up to our underside of slab on grade. At this point in time, you can see the small piece of equipment on the bottom right-hand corner there. We've achieved that level of compaction and level of fill above the geothermal piping, where we can now bring in equipment, and we were building back up, compacting everything, and then actually trenching in other services over top. So going as deep as we did with our excavation, it allowed us to kind of go this route, which is much more efficient and quicker, without risking any coordination or clashes with the geothermal piping runs below. So there's quite a bit of space between those two systems. Even with the sanitary being a long building, we had a lot of slope to account for, but going with the excavation depth we went with avoided any issues with those two systems. And lastly, you can kind of get a pretty cool overview of how this all came together. So obviously, approximately 100 wells across the entire site, runs of piping between every length of footing, every grid line of the building. We had piping connections running everywhere. And that's all consolidated to those 14 pipes you see in the middle there. That forms our manifold or our piping header in the geothermal mechanical room. So obviously those will then be branched off and connected to various heat exchangers. But this is basically where we're at right now on the site. We finally finished all of that underslab piping, and we're now slowly completing our backfill. And on the right hand photo there, you can see our first sections of our concrete slab on grade have been poured. So pretty exciting stuff to see, and it's pretty wild the amount of work and the amount of people involved and how spread out that operation is. And again, at the end of the day, it all kind of ends up with those 14 pipes in your basement. So pretty interesting stuff. Lastly, sorry, just before operation, I'll touch quickly just on construction schedule. So obviously pretty hot topic with trying to phase this into your building construction. I've gone over how difficult this has been through the early stages of the process, and just how how much of a challenge that represents. The trade-off is obviously there's a lot less mechanical equipment to install the later stages of your project. So cooling tower, those types of things that you're not having to deal with that towards the back end of the project. So in theory, it appears that you're just really front loading some of that mechanical work into your project. But ultimately, the work we're displacing at the start of this project is all critical path stuff. So getting that slab on grade in, that backfill done, that's all real critical path, really important items that were impacted by geothermal versus putting a cooling tower in towards the end of your project. It's not necessarily a critical path item. So just one thing to note is overall there are schedule ramifications to doing the geothermal installation, and it will add to your duration, especially during structure. So if anyone's driving by 575 and is wondering why we're still so far down, that's part of the reason why. Is it's been a big process to kind of get where we are now. So
great, thanks so much, Graeme. The last thing that we'll just touch base on really quickly is operations. And obviously we're not there yet. We have not started operating this building. But what we are expecting is a significant reduction in the amount of natural gas we use and overall lower carbon footprint. We will be continuously, excuse me, monitoring the system. Diverso is going to be helping us out with that. Monitoring, make sure temperatures within the loop, within the building loop, everything is as expected, making adjustments and tweak as necessary. And we really look forward to diving into that phase of the project as well and really understanding the nuts and bolts of that. What we're also excited about is to collect some data and collect some usage information about this building and compare it to our other buildings down the road that were built and constructed using conventional mechanical equipment. And we want to start benchmarking, tracking, and just really seeing what sort of design changes impact use and impact other aspects of the building so that we can make better choices moving forward and always do better moving forward. So although we don't have a lot to say on operation right now today, we hope that in a couple of years when this thing is up and running, we'll be able to report back to you guys with some more information on that front. So that's it. It was a lot. Thank you so much for your time, but we expect that you guys have some questions, so we will just open up the floor.
Yes, thank you very much. That was absolutely astounding. That was very, very interesting. We did go a little long, so we may have to abridge the questions. Now, we do try and leave the Zoom call open until about 10. I'm not sure whether Nastassja and Graeme are available after the sort of formal part ends, but I certainly saw a whole lot of questions in the chat. Maybe we can do a few. I'm not Ted, do you want to run questions? Have you been monitoring them better than me?
Yeah, I can run them. Right. Actually, a really quick question from Harriet. Is the landlord expecting to charge for EV charging?
So unrelated. So the EV charging, so we're going to have a mix of public EV charging stations. So we've got about 30 spaces of surface parking. The first level of parking is actually going to be shared commercial. We have neighboring communities that will share the parking there. So the public EV charging stations will be on a pay-per-use type basis, but the residential EV parking stations, which will be in the lowest level of the parking garage, as a resident, when you come and you say, I have an EV vehicle, I want to rent the EV parking spot. We actually are still trying to fine tune exactly how to best manage that, as it's new territory for us all. But we do have the potential to have dedicated EV spaces for residents.
Okay, there's a question from Darren Borden. It says, does a heat pump act as a good upgrader for the seasonal work? Not sure what that means, but maybe you know.
I don't know if he's able to rephrase the question.
Okay, let's let Darren rephrase it and we'll go on to the next one. Spencer Bardell is asking if there are any geological side effects from the drilling and the expanding and contracting of the bedrock as the heat goes in and out.
I don't know that we saw that. We drilled through the winter and through, I think our peak drilling period was, I believe, February to March. We were in that like early, late winter, early spring period. So I think Graeme would have to comment as to whether or not the guys on site saw anything like that. But as far as like geological implications, we've got water in our pipes. We're not too concerned about leaks or any sort of environmental impacts from that. Obviously, there's disruption to the neighbors and the surrounding community that has to put up with all the noise. But the feedback from the neighbors that we got was that the bedrock chipping that we had to do before the geothermal well install was actually worse than the drilling for the geothermal wells. So Graeme, I don't know if there's any comment on the any sort of temperature issues.
No, never really encountered that. We had obviously, again, building sciences on site inspecting our subsurface conditions before any backfill or footings went in, and really no degradation of the rock was experienced as a result of drilling. So,
okay, quick question from Steve Isco. What is the estimated payback time to recoup costs?
We didn't exactly look at it that way when we were evaluating this. Again, it was seen as like a long-term investment, and because we there's a lot of variables involved in this. If all of a sudden carbon prices jump next year astronomically, your payback is going to be a lot shorter than if these increases in taxes aren't realized. So it wasn't exactly based on any sort of payback analysis. It was basically we looked at it more for a risk assessment of how much exposure are we putting ourselves to if we don't do this.
Okay, let's go to a live question. Nathan Splinter from Queen's University has his hand up. Nathan, are you there?
Unmute. Yep, I'm here. Yeah, Natasha, maybe this one's more for you. Has there been any sort of consideration for like the long-term strategy, considering the wells are under the building? You're going to own this for a long time and operate for a long time. Do you have any sort of projections on the lifespan of that well field and how you might address it at end of life?
So when I asked this question of the designer, the response was, provided that we maintain that temperature balance and we're monitoring the system, the well field will last. It will. The pipes are really the only thing that degrades the material used for the pipes is sunlight, and they're not going to see any of that. So there was really no concern about. End goal is that this isn't really, we're not thinking about the end of life, is that we're going to maintain this and operate it and have it functioning so that it will last the full span of time for this building.
Okay, a question from Mark Sibley. Kingston has many condo and apartment buildings adjacent to the lake. Is use of open loop or open loop coupled to a heat exchanger a good choice for a large building heat pump system in that case?
I think it's something that's worth looking into. It wasn't an option for our particular site. So on this one, I don't actually have a lot of information or experience on what an open loop system would look like. However, similarly to what you described, we do have other projects in our pipeline that are closer to the waterfront and are closer to the lake. And as part of our geothermal feasibility study, we are looking into whether or not there is the potential to use an open loop system. So when we can report back on our operations, maybe we can have some follow-up commentary on that.
Great. Next question, also from Mark, and you sort of addressed this in your talk, but wouldn't deeper wells minimize the concerns about heating, cooling balance? What are the trade-offs?
Yes, like in theory, you can go deeper, you can put more in shallower. It really, you're in the point where you've got your equation with all your variables and you're increasing some and decreasing the other, and you're seeing where you fall as to what makes the most sense for the system. Like Graeme said, you're going through a drill bit a day, just going 400 feet deep. If all of a sudden you start going deeper and deeper, you've got schedule implications, you've got cost implications. It gets more expensive to drill. So it's going to be unique to every project, how deep and how far you go with everything. But there is a point where that equation of variables, you find the balance for it.
Okay, next question. I'm going to group the next two from Atma and Matthew. Atma asks, how widely available are contractors who can complete the geothermal specialty? And Matthew asks, how much extra training was needed for the trades and subcontractors to work on such a project that was new to them?
Graeme, you want to take that one?
Yeah, for sure. So it is actually, it's kind of a multi-part question. So there are obviously various different contractors involved in that installation. You obviously have well drilling contractors, and we had a specialty contractor doing the piping connections and installs themselves. So both of which, the well drilling probably a little more common. They would typically be the same kind of crew that would install a water well on a residential property. But when it came to the piping connections and the horizontal loop, that was a specialty geothermal contractor. So so far, it seems like there are a few other there's a few outlets in Ontario, but I think as the popularity of these buildings increase, that may be a concern in the future. But as of right now, we were able to retain them, so that's all we were concerned with.
Okay, what is the? Sorry.
Yeah, maybe one more. Give us enough time to do sector news, and then we can continue on if the presenters are available.
All right. So Devin Lake asks, what is the ventilation strategy for the units? A central system with heat recovery or compartmentalized?
So we've got a mix of studios and multi-bedroom units. So the studios are taking fresh air from the corridor. So they're part of the main central system, and there's makeup air units on the roof that will feed the studios. And then in the 2-bedroom, 3-bedroom, 4-bedroom units, the heat pumps actually have a ERV combined in them. So they're a heat pump ERV combined in one. So they'll be getting their intake and ventilation from the outside, just outside the unit.
Okay, back to you, David. And if you have more questions, hold on to them. I don't know if Nastassja and or Graeme could stay after.
I have time to stay. So I knew we ran long. I'm sorry, everyone.
All right.
There are a lot more questions, which is a good thing. Okay, I'll leave it.
Which is a marvelous thing. But yeah, let's try and wrap up, and end with the normal stuff. So what we typically try and do at the end, and we've gone back and forth on whether this should be at the beginning or the end, but the juices tend to be flowing a little better at the end. We try and talk through sector news on top of whatever the topic was that day, just to see if people have highlights. So going down the sector news, anything people want to talk about on fuel cells? Anything new and interesting on solar?
Yes, Kingston 350 is still looking at trying to get council to consider a solar farm municipally run and operated. Failing that, a solar cooperative.
Perfect.
I have a
Maybe,
quick.
I was just going to say when that's a little further along, maybe that'd be a good topic for a switch meeting. Spencer, yes?
Just a quick solar battery car bit of news. Sona Solar Scion is an integrated solar panels into an electric vehicle that produces enough electricity during the day to charge the battery for about 35 kilometers. And it's going to be in the $25,000 price range, debuting in 2025, possibly. So it's very exciting. Also with sharing and renting, and it also has an 11 kilowatt output, so it could charge another car or power a house. The other bit of battery news is Dubai has one of the largest solar farms, and they've just switched on their Tesla batteries. It's a 1 gigawatt, it's over a 1 gigawatt solar farm with Tesla solar battery backup.
Wow. And that solar car, given that most people drive 35 or 40 kilometers a day, you could run your car and not have to worry about plugging in. That would be very, very cool. Anything else on solar? We'll move on to bioenergy. No, we've touched on EVs. Anything else on the EV front? I was quite thrilled to hear all the people driving EVs on the call, but we do preach to the converted.
I just want to point
Sorry?
out that Loblaws has finally put on the road their first reefer truck that has solar on the roof of it.
That's a good start, and we'll mix it in with some hydrogen long hauls, and away we go.
Hey, David, I also wanted to mention that August of this year was our biggest month so far for the public EV charging network that the city runs. Over 13,000 kilowatt hours of power dispensed. I don't know whether that's because people are driving more or we're just seeing more EVs on the road. I think it's probably a little bit of both. But anyways, good news. It seems like the lull during the deepest part of COVID is gone, and EVs are showing up at our stations again.
And that's even higher than when you weren't charging for the electricity use.
Oh, double. Yeah.
Wow, that's awesome.
Yeah.
Yeah. Anything else on transportation as we switch from EVs? No?
Yeah, I was just
Anything
going to
else?
say, I don't know if the school board has been contacted, but certainly EV or hydrogen school buses, definitely EV school buses would be a perfect application rather than spitting out diesel, because kids, there's a rest period between morning and afternoon when they could be recharged.
And there's certainly respiratory issues with the diesel buses. Yeah.
It can also be used as storage because they have a very specific route, and then they are only on, at specific times so that they can be used as grid storage.
Do we know if anyone's working on it, David, Ted, whoever?
I do know lots of discussion when I worked closely with Kutrick about electric school buses because of all the points that were raised here. So not sure where it's gone recently, but yeah, a good idea. Anything on wind? I think okay, we'll move on. I think we've had a really good geothermal that does us very well. Anything on water power, hydro, as we Canadians call it?
David, can I just chime in quickly? I forgot to mention under bioenergy, keep your eyes peeled for an agenda of the Environment, Infrastructure and Transportation Policies Committee in October. There should be a report coming from Utilities Kingston that provides some additional detail on their progress on the renewable natural gas, biogas project.
This is using the Ravensview byproducts.
using biosolids and source separated organics. Yeah.
Perfect. We look forward to that.
Oh, send that along. I'll post that.
Yeah, as soon as it's public, I'll send it to you, Tat.
Thank you.
Okay. Anything on education? Conservation. Okay. Green buildings. I'd say we got that today as well.
Hi.
Yes, Helen.
I missed my I wasn't quick enough when.
Oh, sorry about that.
No, I'm here. Can you hear me? I wasn't quick enough when when you passed through hydrothermal, but I do want to ask, when I built Passive House, of course, I used the modeling software, the extraordinarily comprehensive modeling software provided by Passive House International for the geothermal, for everything else. And I'm curious, now what I built was a single family house. And I'm quite curious, Nastassja, what software you guys use to model the geothermal, or in particular, the HVAC and more generally, or the whole project more generally, modeling software.
I know I I feel silly for not knowing off the top of my head, but if I went to the energy model report, I'd be able to pull up the the modeling software that modeler uses. However, the geothermal designer did have their own software that they kept pretty close to their chest. So I don't have the name of that, but I do know it was a different software than what the energy modeler used, and they did do some reconciliation. And there was some chatter about which was better, which provided more accurate results, but it was not the same software as what they did for the general energy model for code compliance, for example. I'm sorry, I don't have a better answer.
That's too bad. Thank you.
All righty. Anything on collaboration? Maybe I'll just jump in here on something that we're working through. We being Switch have put in an application to the City of Kingston Heritage Fund. And you may go, why would Switch be doing that? But next year is our 20th anniversary, and we would really like to have our archives in order and get some very nice testimonials and video recorded history done. So we put in an application, it went in mid-September, to the Heritage Fund to do a project in 2022, along with hopefully some special events for our 20th anniversary. So there are collaborators involved: Sustainable Kingston, KEDCO, Queen's students are on the docket, so it should be a good project, assuming we get through the vetting process and get approved for funding. So there's something that we're trying to do on behalf of the members to raise our profile and get our ducks lined up as far as what we've done the last 20 years. So kudos to all that have been involved over the years. Anything on policy? And I know we're over time here, so anything on policy? Anything on anything else?
David and all the rest of you, this is Carol. Britain, can I speak? May I speak?
Certainly. Go.
Britain has just released, I think in July, its hydrogen policy. The Netherlands, if you ever want to Google Netherlands and hydrogen, is extremely active. They've already designated Rotterdam as apparently their hydrogen port, and there are electrolyzers going up in Rotterdam. They're using their wind farms as the initial power source to get at the hydrogen, and they're working a lot in China. There's a couple of really interesting YouTube videos on what they're doing in China with respect to hydrogen, the Netherlands. And I do have finally a copy of the Japanese energy strategy with respect to hydrogen, which was the original. They started about 2014, and I think originally planned to have the whole Olympic Village powered by hydrogen. Anyway, I'm finding what's going on worldwide is absolutely impressive. The Japanese are working with New Zealand, apparently, for sources of hydrogen. And already they're talking about converting the big oil tankers into hydrogen carriers. That's about all I have to say, but just sometime when you're interested, just Google various countries and hydrogen policy, and I think you'll be absolutely amazed at what you find is going on. And a little bit of trivia, apparently Germany already has 100 hydrogen refueling stations. Germany is a rather small country, and I think you all know that the EU dictated that all the big transport carriers had to be hydrogen powered, not electric, hydrogen powered. Anyway, that's all I have to say. I found the geothermal presentation fascinating. My question would be, had they looked into a hydrogen fuel cell? because it would provide power and heat. And they're definitely using it in great big buildings in the States, and they put it on the roof. It looks like a great big air conditioner. Especially when I looked at the fine work that has to be done underground to put in geothermal. I investigated geothermal for a property I had in Westport, and I am a big geothermal fan, but it is tricky. And you get something the size of that building that they're working on downtown, and you think, oh, I mean, those little lines are so little, and there's so much weight. Anyway, that's all. Thank you.
Yeah, we'll let this close out. Thank you all for updates on sector news. We probably could have had a whole session just on sector news today as well. Just a real reminder as we close out the formal part, our next meeting is 8:00 a.m. on November 5th. We're still unfortunately working out the final details on who will be presenting, but we will certainly get that out to the membership and the broader social network universe as soon as we have that firmed up. So with that, I'd like to close out the formal part. Again, and Nastassja and Graeme, thank you ever so much. That was absolutely phenomenal what you're doing. You hit all the sweet spots for the techie group that is Switch members. So it was very, very interesting all around. And as I said, Ted usually leaves the floor open. So if you're willing to stay and answer some more questions, we will let those who need to go say goodbye, and we will continue on.
Okay.
Thank
Dave,
you all.
Perhaps I could just read out some of the questions for Nastassja. Thanks so much for staying. So Darren Borden asked, does a reversible HVAC heat pump work as a good heat upgrader or cooling downgrader when geothermal is used as the feed on the fresh air makeups?
So I saw him write that again, and I realized that is beyond me. So I'm sorry, I cannot actually go into the specifics of that question, but maybe similarly or along the lines of evaluating like the system balance and really how to optimize the system. Not on this project, obviously we've committed to heat pumps, but on future projects, we are also looking into other systems where the heat transfer within the units can be shared or distributed before going to the ground loop. And then maybe buffering it a bit there. So we're looking at 4-pipe fan coils, we're looking at 3-pipe VRFs, we're looking at alternate heat pump systems. So we've really dove into this. We have a pre-construction division that basically dives into the nitty-gritty of this and tries to understand the cost implications and the performance implications of these things. So we've committed to understanding this technology, and so we are looking into other ways to see if there's a way to buffer the heat transfer before getting to the ground loop and before having to make such big swings in the ground in terms of increasing loop size and whatnot.
Okay. Another sort of wider question. So this is from Matthew. He says, when I was advocating for geothermal for the new school, there's a new high school in the northern part of Kingston, it was argued that air heat pump exchange was getting so efficient that ground installations weren't worth it. How valid was that argument? Don't know if you could shed some light on that. So this is a school with a big field.
Yeah. So the feedback on our project is that while yes, the air source is becoming more efficient and we've got a wider temperature spread and things are getting better with that technology for sure, it's still not as good as a water source was the feedback that we got. And that's also the feedback that I got from the pre-construction team, is that if the air source is doing a lot better and it's improving and the technology is great, but it's still not as good or not as efficient as the water.
Okay, great. I have a couple of, sorry.
Yes, I'll jump in there. I did mention I'm getting an air source heat pump installed on Tuesday because my furnace died in August. That said, I am having to install a gas furnace backup. I could have done an electric furnace or a gas furnace. and there were pros and cons to either of those, but air source, even, if I, gone to the moon on cost, they're still not efficient enough that you can run them 100% of the time. So you are still dependent on a backup system of some sort or other, at least, on a residential system with commercial products available. So that sort of ties into what Nastassja said, that, if I'd gone ground source heat pump, I probably could have done away with any sort of gas backup.
Great. I have a question. How does using geothermal affect the rooftop, which I guess often is, there's a lot of HVAC up there, but if it's geothermal, for example, do you get extra value for the residents from rooftop freed up or anything like that?
Yeah, so when this building's got a lot of history. It started, I think, if you're familiar and you follow the development in Kingston, it started maybe like 10 years ago was when this project first started. And when actually I got involved in the project at the start, we had plans for a cooling tower and a chiller, and we had to allocate the appropriate space on the roof. Pretty early on in the process, we said, you know what, we've got the opportunity for the geothermal. The ground conditions are great. The building footprint is large. The height is manageable. So let's do it. And so as a result, we were able to delete the chiller cooling tower for the roof, take back a lot of space as rooftop amenity, which was great for the residents. On other buildings where on our particular building, just because of the zoning and whatnot, we did not have the option to switch out rooftop area for units, for example. But if you consider like condominiums and whatnot, where they're looking for, where you need to justify the cost of geothermal more, one thing that could be looked at is like, yes, I don't have all this mechanical equipment that I need on the roof. I can significantly reduce the size and the footprint of the large equipment of the roof. I've now got roof penthouse space. Can I put another unit up there? Can I make another sale of another unit of a premium unit to offset the cost of what I'm putting in the ground, and maybe help
or put up solar
or put up solar. There's more roof space that you could do other things with. But again, it depends on your project goals and who your stakeholders are as far as what they're going to want to do with that. But there is the opportunity to use that space for other things, for sure.
Great. And one more question for me. And this is looking maybe far in the future when you might have two large buildings using geothermal beside each other. And here in Kingston, so we have limestone as the bedrock, and it's porous, and so water can flow, and presumably some heat can move. I don't know the numbers, but presumably some heat can move slowly through the. How does that? Have people thought about? And I know this doesn't apply to your single building, but have people thought about what the implications of that are?
I actually thought about this exact question earlier today. I was like, what happens when all of a sudden every single building has got geothermal and they're all putting heat in and taking heat out, and what does that look like, and what do you do? I was trying to think, like, I didn't actually have any conversations with the designer on this, but I think really it comes down to this idea of you need to make sure that you're balancing your system every year, so that on the aggregate you are not swaying things, and then it's almost like you have to expect that your neighbors are doing the same, and everybody that's all taking from the ground is doing the same. And it would be really part of our responsibility as building owners and managers to make sure that we're doing that for our own building performance, but also as this becomes more common and mainstream and widespread, that it will one day be an issue. But thankfully today we've got lots of space, so we're just focusing on ourselves right now. But I did actually think about that earlier.
Can I ask a technical one? The boreholes, how wide are they? And you put both the heating and cooling loop down the same hole?
It's an 8-inch borehole, and it's the same loop. It's just one pipe, so that comes off every reel is custom made and custom cut for sites. So when you dictate you're going to have a 400-foot borehole, you get about basically a 410-foot length of pipe wound onto a reel, and that's fed through from the midpoint essentially. And so there's a significant bend at the bottom, and then it's just straight
on both sides going up.
Yep, exactly.
Do you worry about stress fractures in the plastic on that bend?
No, that's it was what it was essentially designed to do, and it comes off the reel actually with that bend already in it, so it's already been basically pre-formed on those
cool.
kind of those site-specific reels essentially. So
right, neat. Okay. Another one I've got. I think Podium, when I was reading on your site, you sort of pride yourself in design, build, operate. Is that what you're doing with this one?
It is.
And does that impact?
Go ahead. Yeah,
it is. Okay.
Yeah.
No, I'm just wondering, does that impact, if you're not going to do the operate part, are you less interested in doing the extra upfront to make it, as efficient as possible? I mean, I think this is the win-win for everybody, but.
Yeah, and I think that's the question that, for example, like condo developers are coming across, is that they have to understand or come to grips with, okay, we're spending this, but are we seeing how much of the savings is realized? And with the project financing that's available out there through companies like Diverso, for example, they will basically put in, they will pay for the system so that the developer doesn't have to front that cost and doesn't have to have that question about what am I getting from this? And it's just important then that it's really clear at the point of when you're transferring over the building to the condo, that they understand, like, these are the terms that we came to, and usually those agreements are in the span of like a 30-year contract where you are paying back the cost of the bore field install over a span of 30 years, and the price is fixed from year one, but there's an incremental increase with inflation over time.
I see Nathan, oops.
Yeah, so sorry, I was gonna say, and then at the end of that 30-year period, the condo then owns the bore field. So then they are no longer paying to the geothermal utility.
I see Nathan had his hands up.
Thanks, Ted. I have a comment and a question. We've looked at this extensively too at Queens, because we obviously own and operate our buildings for a really long time. So there's actually like a lower total cost of ownership, after about 20 to 25 years with a geothermal system, even including initial capital costs, just because of where carbon pricing is going and where natural gas pricing is going. And if you can manage your global adjustment, if you are a Class A account, then you can find some lower electricity pricing too. So that's just a general comment. Like in terms of like this technology, it's definitely viable both commercially and for obviously organizations that are in it to make money. So that's just a general comment. I did have a question though, Nastassja. You mentioned that sort of the height of the building and the footprint of it was sort of, two attributes that led to the system kind of being they benefited the design, obviously. So, I guess where I go with that is from like as a resident of the city of Kingston, not taking off my Queen's hat. And, I wonder, is there bylaws that need to be in place then? Because obviously if it was a 30-story development, the technology probably wouldn't work. You'd have to have boreholes that were so deep because your footprint didn't match up with the height of the building, and your square footage was just so large that you couldn't put this system in anymore. So is there like what I heard when you said that was like, oh, maybe we need a bylaw that makes sure that, like, if you allow 30-story development, you can't apply that technology anymore. So that's kind of like an interesting connection between some of the bylaw constraints, and I know developers are already constrained a ton, but it seemed like an interesting one. So I don't know, it's just more of like a general thought in terms of, how bylaws could potentially almost encourage by constraining, the selection of geothermal. Any thoughts on that?
Yeah, I don't think I'm one to comment on what bylaws should be in place, but it is, I think the bigger statement from what you're saying is that this is relatively small right now. Like, we're the first multi-unit residential building in Kingston, and it's a good step forward and it's the right step forward. But like you're saying, there's other things that now we need to start thinking about and we need to start considering as it does potentially go more widespread, and does the technology eventually will probably become capable of expanding to more. So I think it's just important that the discussion keeps going, and that everybody is thinking about all of these other pushes and pulls that could have an impact overall for everyone.
I think also I like the question, Nathan, because it's been a bit of a bugaboo of mine, whether or not, from a policy perspective, who's protecting the geothermal resource and making sure that people's investments are protected. I think, it's kind of similar to what we do with groundwater, where existing users are protected from new development by requiring new development provide the science that shows that their proposal won't harm the amount of water or quality of water that existing users are getting. So I could see us going down a similar path with a geothermal resource.
That's cool. It's related. There's a question here on the chat from David Wilson, says, is heat part of mineral rights in Ontario? But I think, Paul, you sort of addressed that the city could say, if you want to do something with the heat in the ground, make sure you're not affecting an existing
it could be. There's no policy around that right now. Yeah. But as this becomes more common, I think it's going to have to show up.
Right. Same thing with solar. There was, when solar panels first went up, there was no existing policy about what if you block somebody else's solar panels, and is that an impediment to developing solar projects in urban areas if all of a sudden somebody blocks your solar panels? So I hope that answers David's question. There was a question from Matthew Venter. Oh, yes.
Yeah, can I just say, because my question is related, this lends itself to the question, shouldn't the city be getting into district heating? Because if it was centrally operated, centrally built, and provided the service to everybody, it could be done cooperatively. And then you wouldn't have the question of property rights and you'd get to, it would be done as a public service.
Yeah, I can even imagine, for example, if you're going to generate some electricity from biosolids or something, you have some waste heat. Why not put it somewhere where you have a building that's going to use the excess heat? And
in Sweden, I read, I think in Stockholm, they were using the heat from the sewer system to balance heat, to provide energy.
Yeah. Any responses to Matthew?
Well, I guess it comes back to the comment that it's going to eventually grow into a bigger picture than just a single building, especially as more buildings adopt it and it becomes more dense throughout the community. It's something that municipalities are going to have to think about and work through.
Mark Sibley has his hand up.
Could you say a little bit more, Nastassja or Graeme, about the HVAC units within each unit? Is it forced air coming out of the heat pump with ducting, or how does that work?
Yeah, we went with ducted systems throughout the unit. So it would be the same. It would be the same system that you would go with if you had your central boiler, chiller, cooling tower. Literally, the system doesn't know the difference as to whether or not you are connected to a geothermal loop versus the systems on the roof. That was an early choice we made, probably a little bit out of some hesitancy. It was a new technology. We weren't sure exactly where things were going, and in the early days, everybody was a little apprehensive, and we wanted to make sure that there were statements of like, well, absolute worst case, what if this happens and we need to connect it to something new? What system can we use that can be adaptive? And so I think it was a good transition piece, a good transition piece of an equipment. But like even just with this one project, I think we've got a lot more confidence in it. We're excited about it. And like I said, now we're looking into maybe more refining what we're using in the units a bit more, becoming a little bit more creative with the solutions there, because we're not necessarily thinking, oh, if this doesn't work, we have to do this. So yeah.
Just to follow up on that one, is it, so are they're heat pumps, right, in each unit? Yeah, so water to air heat pumps. Yeah, okay.
I don't know if there's any questions out there. I don't see any more in the chat, but I may have missed one. And if not, we're almost at 10 o'clock. So maybe we'll I'm going to give an extra last thanks to Nastassja and Graeme for staying a little bit of extra time. And I know our community is really interested in this project. So thanks so much for being here today and answering all the questions, and a very extensive presentation. There were a lot of positive comments on your presentation. So it was a great job, and thank you so much for doing this.
Yeah, thank you so much for having us. Like we said, we're excited about it, and it's exciting to share what we're doing. So it's great to be here. Thanks so much.
Okay, we're looking forward to a lot more geothermal projects in the urban part of Kingston. Okay, everybody, see you next month, and take care.
Thank you all. Bye for now.
Thanks, everyone.
Thank you.